Alright, so in this video we're going to solve a system of equations, specifically 3 equations, and we're going to use the substitution method to solve it. So the first thing you do is you always want to label your equations just to keep everything nice and ordered. So we'll label them 1, 2, and 3. And next thing that we want to do is we want to solve for x. So we'll say solve for x. And we're going to use equation number 1. So we'll just put equation number 1. Alright, so if we look at equation number 1, we have 3x. We'll move everything over to the other side, and it becomes negative 2y minus 2z plus 4. We divide the left side, we divide the entire right side, and we get x is equal to negative 2/3 y minus 2/3 z plus 4/3. Okay, so once you're done finding the x, then we want to substitute that x. So substitute x into equation and we'll say equation number 2. Okay, so when we substitute x into equation number 2, we get negative 6 parentheses minus 2/3 y minus 2/3 z plus 4/3 parentheses plus 4y minus 2z equals negative 9. Alright, we want to distribute, and when we distribute we get a positive 4y plus 4z minus 8 plus 4 minus 2z, and that again equals negative 9. We want to now combine like terms. So when we combine the 4y and the 4y, we get 8y. The 4z and the negative 2z, we get plus 2z. We keep the minus 8, and again it's equal to a negative 9. We bring a positive 8 over to the other side, and we get our new equation of 8y plus 2z equals negative 1. And we'll call this equation number 4, again to keep it nice and ordered. Alright, now we need to substitute the x into the other equation. So we'll say substitute x into equation number 3. And when we do that, we get 9 parentheses negative 2y divided by 3 minus 2z divided by 3 plus 4/3 parentheses minus 2y plus 2z equals 10. Again, we distribute and we get negative 6y minus 6z plus 12 minus 2y plus 2z equals 10. We again combine like terms. We get negative 8y minus 4z plus 12 equals 10. We bring the negative 12 over, and we get a final equation of negative 8y minus 4z equals -2. And we'll label this equation, equation 5. Okay, now that we have our two new equations, we want to combine those equations. So we want to combine equations 4 and 5. And then we'll use elimination to get to a single variable. So when we combine those two, we have 8y plus 2z equals -1. And we have -8y minus 4z equals -2. And when we look at both those equations, we see if we add them together, we would cancel out the 8y and the -8y. So that becomes 0. And we're left with -2z equals -3. When we bring over the -2, we see that z is equal to 3 over 2. Okay, so now that we have our z, we want to plug in z value, into equation 4. So this is equation number 4, and we get 8y plus 2 times 3/2 equals -1. We get 8y plus 3 equals -1. We bring the 3 over, and we get 8y equals -4. We divide the 8, and we see that y is equal to -1/2. And finally, once you have all that information, we draw a line, and we want to plug in z and y into equation 1. And what we get is 3x plus 2 times -1/2 plus 2 times 3/2 equals 4. We get 3x minus 2, minus 1, make that adjustment, plus 3 equals 4. So we get that 3x is equal to 2. Therefore, x is equal to 2/3. So now that we know our x, our y, and our z, we can write our solution. So our solution is 2/3, comma, -1/2, comma, 3/2. That's how you solve a system of equations, first using substitution and then using elimination.